Hello everyone, welcome to MathSci Logic. So in the video series of solving the previous year question of CSIR-UGC net, we have already solved 6 topics. Now we will go to the 7th topic, which is Schrödinger equation. So in this topic we will solve 6 to 7 questions, I think. Then it is a big quantum mechanics is a big chapter. So actually there are, I think, 30 approximately 30 topics there. So now we will move to the question of Schrödinger equation. And so the first question from the Schrödinger equation is the eigenenergy in the ground state and the first excited state. So here this is the ground state and the first excited state of a particle of mass m is equal to 1 by 2 in a potential Vx. So the potential is Vx dependent on x are -4 and -1. So the ground state energy is -4 and first excited state energy is -1. Where h cut is written in units, h cut is equal to 1. If the corresponding wave functions are related by psi1 is equal to psi naught x, it means the energy of ground state and the wave function of ground state psi naught x related to psi1 x as psi naught x into sine hyperbolic x. Then the ground state eigenfunction is. So we have to find the ground state eigenfunction. Then we will have both ground state and first excited state eigenfunction. Okay. So how do we solve it? So let's write the solution. So first let's write the given values. What we have given in the question. So first thing is ground state energy E naught is equal to -4 and first excited state energy E1 is equal to -1. Okay. Then the mass m is equal to 1 by 2 and h cut is equal to 1. The relation between wave function is psi1 x is equal to psi naught x sine hyperbolic x. Okay. Now we will write the Schrödinger equation. So the general form of Schrödinger equation is minus h cut square by twice m d2 psi upon dx square plus v psi is equal to e psi. It is like h psi is equal to e psi, where Hamiltonian is minus h square by twice m d2 upon dx square plus v. Okay. So now we write the Schrödinger equation for ground state. Ground state. So the value of h cut is 1 and m is equal to 1 by 2. So this will be cancelled out and the whole value will becomes 1. So we are left with minus d2 psi 0 x upon dx square plus vx psi 0 x is equal to the value of e is -4. So this will be -4 psi. Let it write it at equation 1. And for the this is for the ground state. So for the first excited state, This will be minus d2 psi 1 x upon dx square plus Vx psi 1 x is equal to the first excited state energy will be minus 1 into psi 1. This is going to be psi 0. Now, and we have the relation. And we have the relation psi 1 x is equal to psi naught x sine hyperbolic x. Okay. So now what we will do, we will try to find d2 psi 1 upon dx square. So first, let's the first derivative of wave function psi 1 x. D psi 1 x upon dx square is equal to, so what we can write here, just first derive the write the derivative of psi naught x. This will be d psi naught x upon dx square sine hyperbolic x plus sine naught x d sine hyperbolic x upon dx. Oh, sorry, yeah, this will be dx. So we can write it as sine naught dash x sine hyperbolic x plus sine naught x sine derivative of sine hyperbolic x will give cos hyperbolic x. Okay, so this is psi 1 dash x. Now the second derivative, again differentiate psi 1 dash x, that will give psi 1 double dash x is equal to, first differentiate this part. So this will give psi naught double dash x sine hyperbolic x plus psi naught dash x. We will now differentiate sine hyperbolic x, will give cos hyperbolic x plus, now the differentiate second part, psi naught dash x cos hyperbolic x plus psi naught x sine hyperbolic x. Okay, so we have d2 psi x upon dx square. Now put this in Schrödinger equation for the first excited state. So the Schrödinger equation is here, equation 2. So we will put here minus sine naught double dash x sine hyperbolic x plus sine naught dash x cos hyperbolic x plus sine naught dash x. So this will be 2 sine naught here. This will be twice of the 2 sine naught x cos hyperbolic x plus sine naught x sine hyperbolic x, and then the potential part, that will be v naught x. Okay, and here it will be there is psi 1 x, so this will be written as psi naught x sine hyperbolic x is equal to the minus psi naught x sine hyperbolic x. Okay, because here we have Vx psi 1 x, just put the value of psi 1 is equal to psi naught x sine hyperbolic x, and here minus psi1. So now just open the bracket. This will give us, oh sorry, we will open the bracket here. This will give us psi naught dash x, and write this part with double derivative plus v naught x psi naught x, and take sine hyperbolic outside, minus twice psi naught dash x cos hyperbolic x, minus psi naught x sine hyperbolic x is equal to minus psi naught x sine hyperbolic x. So this two will be cancelled out, and this is the Schrödinger equation of left side of the Schrödinger equation, or you can say Hamiltonian of ground state, left side of the Schrödinger equation of ground state wave function. Okay, so here we can write it as a minus 4 for psi naught x, because you can see here this value, this is equal to minus 4 psi naught, and this is going to be sine hyperbolic x minus 2 psi naught dash x cos hyperbolic x is equal to 0. Now just take minus 2 sin naught dash x cos hyperbolic x is equal to, take this to the right side, 4 sin naught x sin hyperbolic x. This 2 cancels 4 and give 2, and here what we are left with, d sin naught x upon dx is equal to minus, take this minus right side, 2 sin naught x sin hyperbolic x by cos hyperbolic x will give tan hyperbolic x. Okay, so to solve the sin naught x, we will integrate d sin naught x. So just write d sin naught x by, take this to the left side, sin naught x is equal to minus 2 tan hyperbolic x dx, integrate both side. So left side will give log sin naught x is equal to, and this side will give minus 2 log cos hyperbolic x. Okay, so here log sin naught x is equal to, take minus 2 inside the log, it will cos hyperbolic minus 2 x. So we can take anti-log both side, and this will give sin naught x is equal to 1 upon cos hyperbolic square x. This will give us sec hyperbolic square x. This is the solution. So let's look at the options we have. A is not the solution, B is not the solution, C is the solution. Sin naught x is equal to sec hyperbolic square x. Okay, so C is the solution. Now we will solve next question in next video. And so thank you, and let's meet in the next video.